When we speak about number patterns, there's a few steps we can take to solve a pattern. If you look in your textbook right now, you see a bunch of number lists, and then they say, write the next 3 terms in this number pattern. And often you guys just see the pattern. You can see, oh yeah, it's jumping by 2, or so sometimes you just solve it without thinking about it. But today I want to teach you 5 steps that you can always use to find the next number, because there's different ways in which a pattern can form. So the first thing is that you need to know a lot of patterns are either plussing or minusing, and those are called constant difference. So in a pattern that's called a constant difference, it means I've plussed or minused something. So if I go from 5 to 3 to 1, then I've minused 2, okay? Then we also get patterns where I'm not plussing or minusing, but I am timesing or dividing, and those are called constant ratio, okay? And that we do that in order to get the next number. So sometimes I half the numbers. You've seen a pattern where I half each time. Then the pattern would go 100, and then 50, and then 25, and we'd have to half each time to get the next one, and that is then a constant ratio. Okay, so just know those 2 terms when we speak about patterns. We're now going to write down finding the next numbers in a row. I'm going to try and color code this. Let's just make the numbers in color. Step 1. The first thing you need to do when there's a row is check them out and make sure they're in the same unit and that they have the same amount of decimals. I'm going to use an example now. So maybe I should start with my example. If I have got 0,125 and then 0,25 and then 0,375. If I look at that, these are all in decimals, so that one thing that's fine. If I have common fractions and decimals, I'm going to firstly try and get them all to be common fractions or all to be decimals. Okay, so, or if I've got centimeters and millimeters, I'm going to make them all centimeters. So you want to make sure that you have the same unit, but then also the same amount of decimals. This one has 1, 2, 3 decimals, that one has 2, that one has 3. It's not so easy for me to see what's happening here, is it? But if I change it and give it all the same amount of decimals, the pattern is going to look like this. 0,125, 0,250. All I've done is I've put a 0 at the back. Am I allowed to do that?
Yes.
Yeah. And then, okay. Now, pretend that these were not decimals. What do you notice?
They're all jumping 125.
There you go. It's 125 plus 125 is 250. 250 plus 125 is 375. Now tell me what my next one is going to be.
500.
It's going to be 500, but in fact, the answer isn't 500.
No, it's 0.5.
The answer is then 0,5, but which is the same as 500 in a decimal. Okay, so do you see how easy that made it? So let's write tip number 1 in words. Tip number 1 is get the same unit, and when I say unit I also mean make them all common fractions or all decimals, and make them the same amount of decimals. I'm going to go on to the next slide. If you still have to copy, I'm going to send you a copy of this and you can do that later. Okay, so if you fall behind a little, that's fine. Next. Number 2. Okay, subtract two sets of numbers from each other. So the first thing you always do, let's have a look at an example. If I have the numbers 302 and I have 325 and I have 348 and I have, well, let's first just do those ones. Then okay, so to see what pattern this is making, the first thing I'm always going to try and do is minus two numbers from each other. Okay, we're going to do 2 and then another 2. So I'm going to say you have to subtract two sets of numbers from each other. So here's what I'm going to do. I'm going to start at the big one. Okay, I'm going to say 348. So I'm starting there. 348 minus 325. And that gives me 23. Then I'm going to do the same. So I went from here to here, I minused, and then I'm going to just check out the same there. I have to do it at least twice. Now I'm going to do 325 minus 302. Oh, I'm getting 23 again. Voila. Now I know there's a difference of 23. Is the numbers getting smaller or bigger on my number line? They're going bigger in this pattern. So I'm obviously not minusing 23. I am plusing 23. So my next number here will then obviously be 348 plus 23. So that's how I knew that I had to plus 23 is I did a minus sum. So to summarize, what you need to do secondly is always subtract two sets of numbers from each other, and that will give you a constant difference if there is one. If you've done this and your two answers are different, then it means there isn't a constant difference. Then we need to look for something else, because then I don't know what's happening yet. Okay. So step 3. If the constant difference didn't work, then I need to go on to step 3. Then the next thing I have to look at is, let's look at I'm going to do an example. Here's a pattern. 18, 54, 162. Could I find a constant difference there? No. If I minused 106, if I took 162 minus 54, it would not give me the same answer as 54 minus 18. No, don't give me the answer yet. You're too clever. And so my next step is now divide two sets of numbers. So now I'm going to do a division sum, and I'm going to say, okay, to check what I'm doing, let's take 162 and divide it by 54. Now you might be allowed a calculator here, or you might need to use long division. If you have a calculator, it's nice and quick. I get 3. Then remember, you can't just test one set, and you have to start at the biggest one. So I started there and I went back and I did a divide sum, and now I'm going to do the same there. Also do a divide sum. Let's do 54 divide by 18, and I'm again getting 3. Ah, wonderful. I have found not my constant difference, but now this is a constant ratio. All you need to ask yourself now, this ratio, is the answers getting bigger in the number pattern or is it going smaller? Bigger, so I should times. Okay, so I am going to make my summary and say, so in step 3, if step 2 didn't work, you have to go and divide 2 sets of numbers to see if it is a constant ratio. And now I can get my next number. I can say 162. All I need to do now from there is times by 3 because I've noticed that 3 is the constant ratio and that gets me to 486. Okay, step 4. What if none of this worked? I tried to find a constant difference, there was none. I tried to find a constant ratio, there was none. Then there's always step 4. If I use the first thing I would now look for is, look at this numbers and tell me if you recognize them. How about 64, 49, 36, 25? Is there anything familiar about these numbers? They are your friends. You've seen them before. Oh. These are squares. Okay, squares. So, when you see the numbers 25, 36, 49 or 64, then you should recognize them as squares. And you can see, oh, so I took, and to find them, you can go and do the square root of 25, you understand? Okay, just don't do that. So I'm going to tell you that step 4 says look for square or cube roots or numbers. Okay. Numbers / roots. Not just the square ones, but also the cube ones. So sometimes your pattern doesn't want to form a constant difference. It doesn't want to form a constant ratio. It might be a square or a cube number pattern. And then you must keep an eye out open for that. Another set of patterns I've noticed. I'll just get back to there, number 5. What if a pattern looks like this? 2, 5, 3, 10, 4, 20, 5, 40.
It's every second one.
Good, it's every second one. So this is a combination of 2 patterns. And both of them are actually quite easy. They're just combined. So my first pattern, and so here's what you need to do. You just need to look for a pattern.
Because it's 5 in 2 separate patterns.
With every second number. Look here. My first pattern goes 2, 3, 4, 5. So what will my next number be? 6. There. My next number in the pattern is a 6. Then, if you also look at the other set of numbers, I've got 5, 10, 20, 40. What's happening? 80 will be my next number. So there I'm doubling. So sometimes they try and trick you with a pattern that's actually a combination of two patterns. And then if every second number is doing the same thing, then you can figure it out quite easily. These patterns usually look crazy. What happens? You'll notice them by seeing that the numbers are not just going bigger. They're going bigger and then smaller again and then bigger again. And that's when I see that, I always look for a combination pattern.